Next illustration. So, by reading it, it's just the usual three-phase transmission line. Flat horizontal spacing. So, I think this one will fall under unequal phase spacing, no three-phase line. So, it's just that your A is requiring you to get the capacitive reactance to neutral, okay? Neglecting the effect of the earth plane. Ayun, that's the difference, no? While that of B, we are going to consider the effect of the ground. Okay? Okay. So, let's have letter A first, no? So, yung letter A natin will be three-phase line with unequal phase spacing. Okay? Kasi there's no effect, no earth as of, no? The A problem. So, okay? So, redraw lang natin. So, horizontal configuration, flat horizontal spacing. Okay, so, without earth effect, so it's simply straightforward na ulit tayo, no? So, instead of getting Cn muna, tapos, then get the XCN. So, i-plug in na natin agad from XCN, yan, itself, no? Diretso na ln dq over r over 4 pi squared Fe. Pero it's okay, no? If you will start with Cn and then tsaka na lang yung XCN. Okay? Kasi this way can minimize the rounding off discrepancies. Okay, so what's next? Well, it's simply getting the EQ, and the EQ is simply the cube root of those products. Okay, and then your R coming from 3.28 centimeter divided by 2. Okay, and then converted to meters. Okay, so we have 0.0328 over 2. Okay, so that will be simply your XCN, mega ohm meter. Okay, so yun naman yung hanap in the problem. Okay, so next, for 125, kasi hinahanap din pala yung capacitive reactance, of the line. So, hinanap siya, no? So, ang sabi niya is, determine the capacitive reactance centrally normal per phase and the capacitive reactance of the line. Okay? So, hinanap niya in ohm per phase. So, for 125 kilometers of transmission line, so we have XCN here. So, again, it's 1 over 125, no? So, kasi, by default, XCN is ohm meter. Okay? And then, we are getting, and then the given length is 125 kilometers. So, since meter and kilometer, plug in yung 1 over 1,000. So, your capacitive reactance of the line per phase, okay? Per phase ang hinanap, ha? Please take note of that. Nakalagay per phase, no? Is 2,603 ohms, okay? So, I think that will be for showing the effect of, no effect of earth, okay, to capacitance. Now, for illustration, for part B of illustration 6B, so here comes the effect of earth plane. So, three-phase naman ito, diba? So, it's a three-phase line. So, ito yung gagamitin natin. It's no longer single phase. Okay? So, redrawing. So, we have the true conductors. The true conductors. So, yun yung conductors 1, 2, and 3. And then, with the image conductors below the surface, with the following distances. Okay, so with the effect of earth on the ground, with the effect of earth-ground on capacitance, please forgive me for those mistakes. So our XCN is ln of dq over r, and then the GMD between the conductors, the image and the true conductor, and then the self, yung H1, H2, H3, okay, over everything here. Okay, now let us have H12, H23, okay, H12, and then H23. They are just the same, no? They are equal in length, pero how do you get them? No, that's for H12, and this is for H23. Okay, the same siya. So, it will simply be by Pythagorean again. So, yeah. So, we have now our H12 and H23. Now, for another distance, for H31, ayun naman siya. Okay? H31. And then, simply, by Pythagorean then, we have H31, 46.65 meters. Okay? So, I think for that part, okay na tayo. We need the self-GMDs. No? So, for H1, H2, and H3. So, it's a straightforward, okay, distance from the true conductor to the image conductor. Okay? So, we have simply 40. Right? Okay. So, everything ready? So, we get our XCN. Yung DEQ natin is that one previously obtained. Also, your R. Then, here comes the H. And our XCN is now given here. Okay? So, we can compare this actually to the previous calculated XCN. Asan yun? It's 325.49 mega ohms. Okay? 325. So, it's 325. Now it's 321. So, nag-increase siya ng capacitance. So, therefore, your reactance was also affected. And that is by decreasing it. Diba? Kasi inversely proportional siya. Okay? So, you see the effect of the earth na, to capacitance. Okay? So, next thing to get is meron pa ba? Capacitive reactance of the line. So, that is simply having the 25 kilometers as the length. Okay? So, again, over 125 kilometers, and then yung 1 over 1,000 will be the meter-kilometer inversion. So, you have our XN as 2,573.4 ohms. Okay? So, we are expecting na this one is also different from the XCN that we previously calculated for without taking the effect of earth. Okay? I think that would be all for problem solving illustrations for the topic capacitance of transmission lines.